Hello, welcome to today's class. Look at this Olympiad challenge, Olympiad algebra. The question is x to the power of x all raised to the power of 3 minus 3 is equals to 3. So how do we solve for the value of x in this challenge? So if you're new here, this is Math Pros. If you have not subscribed, subscribe because here we release amazing steps to Math Olympiad problem. So let's take our solution. Solution. We have our x to the power of x all raised to the power of minus 3 is equal to 3. The question would have been a lot simpler if this is not carrying a minus exponent. So what we do at this point here, we want to take the natural log to both sides of the equation. This time we're going to use ln base e. Let's ln both sides of the equation. So this is going to give us our ln of x all to the power of x all raised to the power of minus 3 equal to, we also ln the right hand side of the equation. Okay, now if you look carefully, this is the exponent here. So this is the exponent. And here we're going to apply the law of logarithm, which says that if you have log your k to the power of p base 10, then move this backward here. So this is going to give us our p dot our log your k the base 10. All right, so remember this law. Okay, so if we have this at the back of our mind, we can apply that here. So let's move that down to this other side. So if we move that, then this is going to give us here our x to the power of minus 3 close bracket, the ln x is equal to ln 3. Good. So what we do next here, now I want to rewrite this expression here now. So how do I rewrite this expression? Remember that if we have our e to the power of ln, this e the times, let's take this to be our a, this is same thing as a, or this equal to a. Remember this? Why? Because this is ln base e. So this leaves the system. So I want to introduce this and rewrite whatever I have in here. So this will now give us in turn that our ln x, okay, the times our e to the power of ln of our x always to the power of minus 3. This is equal to the ln of 3. So what we do next here, it is easy. Again, we apply the law, which is this law of logarithm here. So if we apply this law, we move this backward here. So if we do that, this is going to give us here the ln of x times our e, okay, to the power of minus 3 close bracket, the ln of x equal to, here we're going to have here ln of 3. Okay, so what we do here, so the only way to solve this challenge or this step at this point is to evoke the Lambert Wn function. And what does it say? It says that if you have, if you have e or to the power of, let's say a, right? E to the power of a, and the base here is also a. Then if you now take the Lambert Wn function, or what we call the product log, okay, this will give us our a. Okay, I know this is not taught in our many schools. Okay, so if we succumb to it, it means this power and the base here must be same. So if they must be the same, then let's check what we have in here. Here we have ln x. Here we have minus 3 ln of x. So for us to make the exponent and the base to be same, we have to multiply by minus 3 to both sides. So if we do that, this is going to give us here our minus 3 close bracket, the ln of x times e to the power of your minus 3 close bracket ln of x is equal to, we must multiply this side by minus 3 ln of 3. it is at this point we can now take our Lambert Wn function, right? Good. So if we do this, we're going to have this to be our Wn bracket, okay, let's use our square bracket here, the bracket here, minus 3 close bracket, ln of x, times our e all raised to bracket minus 3 close bracket ln of x, then close our bracket into our square bracket. This is equal to, we also take the Lambert function of this side, so minus 3 ln of our 3 close bracket. Okay, so what we do here, automatically we're going to have this, or this now implies that our minus 3 ln of x will now be equal to Wn bracket minus 3 3 ln of 3. So this is our expression for that. So how do we get our x here now? It is very, very easy. First, we divide both sides by minus 3. So let's divide this side by minus 3. We equally divide this side by minus 3. So this leaves. So we are now having ln of x, right? Ln x. So with this ln of x, we are going to apply this rule here. So let's introduce e to both sides of the equation. So we're going to have this to be our e, or to the power of ln of x. This is equal to, we're going to bring in our e here also, there into minus the Lambert W function, bracket minus 3, the ln of 3, close bracket, everything all over 3. So again, this leaves the system, right? So we are now left with what? Our x. So we now have, therefore, our x will now be equal to re to the power of the Lambert W, then bracket minus 3 ln of 3 close bracket all over our 3. All right, so this is the value of our x that we satisfy the original equation. Okay, is the value of x that will satisfy our original equation. Now, how do we get the numerical value of x for this? All we need to do is to log this into our Wolfram alpha calculator. Now, n range from 0, 1, 2, 3 to infinity. In other words, we have infinite solution to this expression here. So to get the numerical value to this expression is to plug in n equal to 0. And if we do that in our Wolfram alpha calculator, it's going to give us a numerical value. And when you plug it into the original equation, then it will satisfy this equation here. So if you learned something from this video tutorial, give the video a thumbs up. Not clear with any of the steps, then drop it in the comment section. We are there to reply to all your comments. This is my Proes. Remember, we love you. Bye.